Hello guys, quick update video on what I'm working on right now. Yes, I know I have not yet uploaded the latest video for the last video for the TDAC series, in which we will discuss the Arduino code. I know, I'm sorry, I'm doing what I'm best at, which is procrastinating. But don't worry, I will upload it, I promise. It's just that, yeah, I have not seen the moment. I'm just, very busy and lazy. But I will upload it, I promise. In the meantime, if you are building it and you have questions regarding the code, the Arduino code for the TDAC, do not hesitate to join my Discord server. I'm very keen to help in there to whoever has any questions or doubts. So, and I'm very active in that server. So yeah, I know I've not delivered, but at least I provide support in that channel. So as I was saying, this is what I'm working with at the moment. As you can see, this is the throttle unit of Thrusmaster Warthog. Yeah, that's it. I bought this unit used. I don't remember how much I paid, but I paid. I didn't pay much for it because, well, it was used for once, and also it had a couple of issues with some of the switches, namely the pinky switch, which is very prone to fail apparently. So it needed to be replaced. And so since I wanted to make some mods to it anyway, I took the opportunity to buy it cheaper and then fix it myself. So first thing I did obviously was replace the pinky switch. Very easy to do. I mean, there's not any mystery in these cases. It's just a switch. It unscrews with this nut here. You need to dismount. Take out these screws here. There's a few screws here, and then you can access the inside. Very easy. Unsolder the leads, solder the new ones, and that's it. Something else I wanted to do, you probably have noticed there are no wires coming out of it, and that is because I also have a Win-Win Orion HOTAS, and I like how it unplugs from the front. So what I did was remove the front wire and replace it with a female USB. My original plan was to use a female USB Type B female port, but so that I could simply, to switch between this one and the Win-Win, I could simply use the same cable, but it doesn't fit in this space, and I don't know why, but I didn't want to ruin this plate and the one behind. In hindsight, I could have. I've already basically destroyed it. Not destroyed it, but I could revert back to what it was, but I'm not planning on doing it anyway. So I could actually make this hole bigger and just use a USB Type B female port in here. But whatever, this is what I did. I used the hole that was already in there. This is some epoxy, and the USB-C female port is just attached to it, and it's very solid. I actually tried to pry it a little bit, not too much force, but I did pry it, see how hard it would be to remove it, and I think I would destroy the port. I could probably remove that epoxy, but I would need to replace the port because it's very tightly glued in there. And I know it's white, it doesn't matter. I don't really care. Something else I replaced, as you can see, well, maybe you can't see this one, but this button is not the original one. The original one was too stiff for my liking. So I just replaced it with a normal AliExpress one. It's softer and just, I mean, it's very simple, just same as the pinky switch. You just, it's an easy replacement. Next thing I did was replace the slew sensor. As you can see, at this moment there is a controller type joystick inside here, but my original replacement was one of those that I used for the TDAC, which are the flat ones, these kind of, you know, USBs that don't have the push function, and it's just XY axis in a flat movement. That I actually removed it, and I used I think it's called Delta Sim board. So originally he has I think it's an instructables page where he explains how can you do that with an Arduino Micro. So you plug the joystick to an Arduino, and I used an Arduino Micro, but sorry about the finger. I used an Arduino Micro, but I think you can use whatever Arduino. And then he has some code, and you plug it to the board. There's a board inside here, which these two switches are connected to. So there's a PCB. When I say a board, I mean a PCB. These switches here, these three on the bottom, the China hat, boat switch, and the flap switch, are actually attached to a PCB inside this grip. And these buttons and this one as well connect to that PCB via some Pico Blade connectors. So you connect that Arduino to that board, and in theory it should work, but for some reason mine was not working. So I ended up buying I mean, he also sells this kits with the joystick, also a 3D printed adapter, and also the PCB. I only needed the PCB, so I asked him, and he said he had some left over, so he sent me just the PCB. So I used that with the joystick type that I wanted to use, because I didn't want to use this originally. I wanted to use the flat ones without the push buttons. And I'll come back to this one later, but first let me explain you what else did I do besides that. So I ended up using his PCB, which has some coding to it. I mean, it has a chip and it's coded in a way that it communicates better with the unit. And the last thing I did was replace this China switch, because I didn't like the feel of it. I don't know if it's because mine was used or it was old, or maybe it's like that by default, but it was kind of hard and clicky. And this is a momentary switch, if you know this unit. So it returns back to center. And I just replaced it with a little bit of a softer switch. This one is back to the original, at least the cap, because I had to replace the cap when I replaced the switch. But I've done some modifications that I'll explain now, some more modifications afterwards. And this one, I actually disassembled the switch inside. So the switch, one of these looks on the inside something like this. So you can remove the metal part on top and disassemble it. And that's actually what I did. I used the top part of this switch, which it's flat. Instead of being like this, it's flat and it has a hole in the center, and then this cap is holed. I don't know if you can see, but there is a small hole there, and that's because it has a pin going through the pole. Originally, I just replaced the switch and 3D printed a piece like this one, and that actually did well. But I ended up just using the top part of the original switch. So this and also the pole inside is the original one. and then remove this metal part and replace the inside of the switch with one that I liked the feeling, because that's what actually determines how hard or soft it's basically the inside. There is a piece inside that you can replace. So essentially this is just a mix of two switches, the original part, the top original part, and the bottom is one that I just bought. Okay, so that being said, sorry about the fingers again, I'm using my cell phone. I was ready to use it until I noticed something else was wrong with this unit. Well, a couple of things. One, I needed to replace the autopilot switch as well, because it was giving like bad readings. I guess it because it was old or something. It was whenever I clicked it went crazy a little bit. But the main thing, and I actually had a post in the DCS forum, is that for some reason I had to double input sometimes in order to get action. And by that, what I mean is, for instance, if I had, I don't know, if I had the APU on, I started the aircraft in game, and I wanted to turn off the APU because I had already gone through all the process. Instead of just doing this, for some reason I had to go back to start and then go back to off, so double the input. And if I didn't do that, it wouldn't recognize that input. Sometimes it did happen to me with the idle off to idle. So whenever I moved the lever, for instance, and this happened from off to idle most of the time. If I went to idle, it wouldn't recognize. I would need to go back to off and then back to idle, which is very annoying. It's probably not a super big deal, but it felt like it didn't feel like it was a problem of the unit, but I don't know, maybe the firmware, which by the way I updated to the latest one, or maybe it was a problem with how this unit, which is very tightly tied to DCS bindings, and it's very hard to modify the bindings because they work together in order, so you don't have to do, when you buy one of these new, you just plug it in and you don't even need to bind them. But it felt like it was a software problem or something like that. It didn't feel like it was, because it was recognizing it. It just needed. I even thought it was maybe a special option in the menu. I don't know. It happened the same with the flaps. That was very annoying because if you're trying to take off, I mean, I had to go up and then middle and then up again. Very annoying. And apparently that's not what should happen. So there was something else wrong inside of my unit. So tired of waiting for someone to give me a solution, which nobody was actually able to do, I said, fuck it, I'm gonna screw it even more. And here's the last part of my mod. Yeah, I've essentially gutted the throttle unit, and I'm going to replace all the electronics with an Arduino and make it an HID device similar to the TDAC or the Collective. I'm just going to do another one, which is going to be the Warthog throttle, and just essentially use everything in the unit except for the brains. So obviously I'm going to use the switches, I'm going to use, so for the throttle, this has two chips like this one, which is an angle reader. It's a Hall effect sensor. There are two magnets here, and these go like in here. And these actually read the angle of the throttle. Just a curiosity, when you are in off, in the off position, there's actually not a physical switch that determines that. I'm assuming, because I didn't find it, I didn't take it off. There's not a switch being clicked when you are in the off position. So I assume, and that's what I'm gonna have to do in the Arduino code. It's just reading an amount of angle. So from, let's say, this position up until here, it reads the angle, but if the angle is like smaller than this position, it determines that it needs to virtually click one button, which would be, in this case, the left throttle off button. But again, it's not a physical button. There's actually not a physical button inside for that function. So I already did a lot of it and I didn't record it, sorry, because I was not planning on recording this. I wasn't sure if that would be interesting content, but somebody told me it could be, so that's why I'm here. So here I have it, as you can see, there's no, the friction wheel is not here. I had to remove it. This is held by this bracket in here, and on top of this bracket is where the actual brains, the chip of the throttle is actually there. So I removed that already. I'm only, I mean, if you can see these boards here, for instance, these are just the LED boards. There are a few more behind it. So you can see another one over there. Those are the backlight LEDs. This one here is a board that holds all these buttons here together. So I didn't want to mess with that because it would probably ruin trying to desolder those buttons, those switches. I already tried to do it with these three because I had to replace one of them anyway. So these three are actually soldered together in a PCB, the original ones. But when I tried to remove one of them to replace just that one, it ruined the button because you have to hit it so much that basically melts the plastic case. So essentially I ended up replacing the three of them, even though I only had to replace one of them and threw away the PCB. So for this one, I didn't want to do it. This basically it's a PCB that it doesn't control anything. There's no chips in there. The only thing that's there is a VCC layer, copper layer, and a ground copper layer. So all these switches have one leg in common, which is the ground one for me. I just soldered leads to it. So what I did also, I didn't mention, there's a total of, I believe, a total of what's that? 16 inputs in the right throttle plus 2 analog, right? So what I did is inside here, I removed that PCB I was talking about before. I just kept the switches, replaced them, and you will see that in a later video because I actually want to replace this joystick. This is a standard analog joystick, and later on I thought, why wouldn't I use a Hall effect joystick? So that's what I'm going to do soon. So whenever I do that, I'll open this section of the throttle and I'll record it so you can see it. It's a rat's nest. I can tell you already that there's so many wires in there because I just, cut them a little bit longer than it needs to be, so you have some room to work with, but then you end up with a lot of wires. And because I removed the PCB and basically soldered the pins of these switches independently, there's just a lot of wires. So there's 2 shift resistors here that make 16 inputs, 8 inputs each shift resistor, and then the 2 analog inputs, and then there's 5 in here. And if you go back to the inside, this has a 5. I replaced this connector. This has 5 wires coming from the left throttle. That is because the common wire, they didn't connect. It's just one button and one switch, so that makes 3 for the switch one common ground and the two positions of the pinky switch, and then the other switch is the two legs of the other switch. So actually two of these wires are going to be a ground. And then the other one is the one that has the shift registers. There's a 5 connector here. I also replaced this one. 5 wire connector. These are the 5 outputs of the shift registers inside that that throttle section. So VCC, ground, clock, latch, and data. And then separately the 2 analog inputs. And this connect to this small PCB that I created because I wanted to make it a little bit, I did a little bit of cable management. There's a third shift register here. This is going to be screwed in here. And then the 5 out of these 2 shift registers behind are going to connect to the in here through this connector at the bottom. This connector is connected to the in of these shift registers, and then this shift register has then the output coming out this way, and there's another shift register over there. So a total of 4 shift registers. So for that I have 2 shift registers here that are covering the 16 inputs in the right throttle unit. Then another one here which are covering these 3 switches plus these 2 buttons. You cannot see them, but these buttons connect there, these buttons here. So that's gonna be 1, 2, 3, 4, 5, 6. Am I counting correctly? Oh yeah, sorry. That's 6, and also the flaps one. The flap switch, which is here, comes out of here. So this shift register here is covering those 8 inputs. This is a 3 position, so there's only 2 inputs. This is one input, this is neutral, and this is another input. So 2, 3, 4, 5, 6, 7, and 8. And then the out, as I was saying, is coming to the in of this 4th shift register, which is covering these 7 inputs. And I have one left, but that's fine. And these 5, I will just connect them directly to Arduino. So no shift register for this one since I have leftover pins. So the Arduino, which is right back here, is going to be mounted somewhere in this bracket whenever I put it back. So it's going to be somewhere mounted in here. Also in a PCB, which will have like this connector, and also I need to add wires and connectors to the out of this shift register into the Arduino. And then, so as I was saying, I will need to connect the whole sensors as well. So by the way, I've already found out how to work with this and how to read them with Arduino. Switches are very easy to read, whether you use a shift register or just plug them directly to Arduino. They are very easy. I've done them separately. I just need to consolidate all the readings in one code. So all the digital readings, all the analog readings. By the way, the analogs of the XY, the slew sensor, which are these 2, connect to this PCB as well, just for cable management. But then from here, there are 2 other wires, which I believe it's these ones here. And you can see 3 because there's also this other potentiometer, which is that one over there. So there's 3 analog reading inputs. Those come here, and that will connect to the Arduino from here as well. So yeah, a lot of wires, but I'm actually almost done. And by the way, this is the front connector. As you can see, it's connected to a male USB Type-C, which will be connected to the Arduino. And To power the LEDs, since this is a PCB that just has a couple of planes for ground and VCC, I actually connected ground and VCC from this port, so the power for the LEDs won't be provided by the Arduino, but by the USB port of the computer, which is more capable of delivering power enough to, to power a few LEDs. So I just connected all the LEDs. You can see some red and black wires here. This is one of the boards. There are several boards. There are like 4 or 5 boards. So I connected all the grounds to the same plane and all the red wires, the power to the other ground. And I'm just using this PCB as a power distribution board, kind of. So I connected the VCC from the front port to the same VCC port in this board. I hope it makes clear. I'm not confusing you even more. So yeah, this is my current project. From now on, I mean, there's not much more that I have to do, but the little one thing I was waiting for and was delaying my project a little bit is that there are some O-rings that go in this part of the throttle that were basically destroyed, so I ordered new ones. I need to replace them. There's gonna be like one here, one here, one here, and another one here, so 4 in total. So yeah, I'll just be adding these O-rings there, and then I can put this back, which is holding the levers and also the friction wheel. And then after that, I will be able to basically create the. I'm just going to use. Where do I have them? Here. One of these. I'm gonna cut it to size and just put the Arduino here and a couple of connectors like for this, so I'm able to disassemble it again. I didn't want to hot wire everything, and I mean not hot wire, solder everything, so then I cannot take it apart to service it if I need to afterwards. So there's gonna be connectors for this. There's gonna be like this potentiometer. Well, I already said the 3 analogs will be connected via DuPont cables. Also, the shift register will be connected with wires and a connector, so they won't be connected directly. These ones are already with DuPont connectors as well. So yeah, I'll just build one of these PCBs and wire it from behind, however I see it's best. And again, I'll try to record that in case you're interested. So this is already a long video. Sorry if I bored you. Feel free to skip. But if you made it to this point, thank you very much for following. And yeah, see you in the next update.